Hi all. So right now I'm just uploading a video, so the stream might not be that good. It's going to take about 5 more minutes. Given what I've seen this week so far, give me 2 seconds. Why is that not staying on top? Given what I've seen so far, I think most people want to talk about either of these things. So in the chat, just comment the number for what you want to start with. The first one is just going to be exam information. The second one is pointers, passing, scope, etc. And the third one is pointers. Whoops. Sorry. Second one being functions, sorry. And the third one being pointers. And we can go over pointers right from the start. So in the chat, just let me know if there's something else that you want to discuss. We can discuss that too. So you can add either 1, 2, or 3, or suggest something else that you'd like to talk about. We're not going to talk about assignment 2 yet, though. Okay, I'm going to reserve quite a bit of time just for that and have a live stream specifically for that. Okay, so hopefully the stream isn't too bad right now, but I'm just going to give it a couple more minutes to upload this video, and while we're waiting, I'll just get you to put what you would like to talk about first in the chat. Is there only... I'll just refresh that. I'll just give you a couple of minutes. For anyone that's just joining, keep in mind that this is an interactive live stream, meaning that I need you to tell me that you're engaged. I can't just guess that you're engaged. So you do need to just keep typing in the chat. You can put jokes, you can put emoticons, you can put whatever you like, just to keep the chat moving so it doesn't feel like I'm talking to a brick wall. All right, so we're getting quite a few 3s. Now, the other thing is that your assignment marks have been released, so you should be able to see there now. Keep in mind that it is a 5% assignment, so if you get a 90, it's pretty much full marks. If you get 80, it's 4%, 70 plus, it's still 4% nearly. So as long as you got above 70, you really haven't lost many marks at all. There's plenty of marks to make back up. Okay, so don't stress out, rather use the feedback so that you can get heaps and heaps and heaps of marks in assignment 3 and the exam. All right, let's got 2 seconds remaining. So I'll just copy paste that. While that's loading. So we're getting quite a few people joining now, which is good. just get LMS open as well. Processing. All right. Oh, come on. Let me open this up. All right, it should take a couple more seconds, and then the stream should be fast again. Let me check. What are you running at? 443 kilobytes. So for anyone that's just joining us, as I said, I'm just in the process of uploading a video, so the stream might be a little slow. Once that's done, we'll get started. While waiting, please let me know what you'd like to chat about. As I've said before, this is an interactive stream, so it's expected that you use the chat, and feel free to use it as much as you like. I don't really care what you put in there, as long as it's interactive. That's the main thing for me. Come on, hurry up. What are we running at? Oh, 34. Three. Come on, hurry up. Processing done. All right, that should be a bit faster now. Let me double check what the stream rate is. It's still pretty slow. All right, let's see how we go with that. All right, so welcome to the PES Help Session. So we've got a chat here. I really appreciate if you use it. It makes a huge difference to me, and it will make a huge difference to you, because this is how I decide on what to do, and also how long to take the stream, how much information to give. The more engaging it is for me, the easier it is for me to share as much information as I can. So if you understand something, just say yes. If you don't understand something, say don't know. As simple as that. You're not going to be judged in any way. Okay, it just makes it easier for me. So given what I've seen so far, most people want to talk about pointers, then functions, then exam information. So what we might do is we might look at pointers first, then we might look at functions as a recap. So this is just stuff we did last week. Then we might do pointers and functions together, and then we will talk about the exam. How's that sound? Sound pretty good? If it sounds pretty good, put a thumbs up in the chat or some kind of emoticon animal, and then we'll continue. All right, so with our pointers, the best place to start with our pointers is going to be having a look at memory. So I'm just going to draw a small block of memory here. And if you watched the videos already, you would have seen this, but I think if you haven't watched the videos yet, do so after it because it's drawn a little bit neater, and we can go to whatever detail you want. Basically, memory, what we're talking about here is RAM, okay? And our memory is broken up into bytes, okay? And it means that every byte is addressable, meaning that if I want to look at a particular byte in memory, I can, okay? If I want to look at a particular bit in memory, I can't unless I know the byte in which that bit resides, okay? So I need to know which byte it is before I can look at the bit, but I can look up any byte in memory if I know its address. So when we talk about addresses, every single byte in memory has an address. We're going to keep it nice and simple here. Let's say this is 02, 02, 03, 04, 05, 06, 07, 08, 09, 0A, 0B, 0C, 0D, 0E, 0F, 10, 11. All right, so first things first, you can see that I'm counting up in hexadecimal. Usually when referring to memory, we will be referring to hexadecimal values. Now, this here is a little under-exaggerated. For memory, the addresses are actually going to be a lot longer than this, okay? As you can expect, we do have quite a lot of memory on our computers. So the addresses normally would be longer, but I'm not going to write all those out because that's just a waste of time. So our memory looks like something like this. Now, what we've got to remember is that in our memory, we are not the only program that's running, and we have to share memory with other programs, okay? And so, for example, this block of memory might be used by another program, and our program uses some things around it. If we try and access something that's not ours, our program will crash, okay? So either if we try and read it or write to it, our program will crash, all right? You don't know where your memory is going to be allocated, and you don't know where, why is that doing that? You don't know where the other memory is either, okay? So this is something that's all dealt with by the memory management unit on the computer, and that makes it easy for us, but it also makes it a little hard as well because we don't get to tell the computer where we want to put something, okay? Now, the other thing that's important is that we have different types of systems. Now, C is a system-dependent language. Okay. Now, anyone that's done something like Java will know that that's a system-independent language, meaning that it should run the same on any system. And it does that by running not on the operating system, but rather on the Java virtual machine. C, on the other hand, will change depending on the system it's running on. So, for example, if you run it on one computer, it may be different than if you run it on another computer. And there is a lot of variables, but the one that we're going to look at today is going to be the computer system itself and its address size and the size of an int. Okay. So we're going to assume that we're using a completely 32-bit system. Okay. This means that our addresses are all 32-bit. And our ints are also 32-bit. Okay. So 32 bits in bytes is, put it in the chat. Where's that chat? I might actually make this a little bigger as well. Beautiful. So it's 4 bytes. Now, if you don't know something, just say don't know in the chat. That's what I need to hear. So if you don't know something, just say don't know. So it's going to be 4 bytes. How do we get that? Well, we just divide by 8. Okay, so 32 divided by 8 gives 4 bytes. Okay, and our ints is also 4 bytes. All right. So that's the first thing. Okay, and we need to understand that at the start because we need to define that at the start before discussing pointers because I can change things around and my examples are going to be slightly different. Okay, so we've got 4-bit addresses, 4-byte addresses. So these should be a little bit longer, but I'm not going to write the full thing out. Okay. Now, the next thing we're going to do is we're going to have a look at how a variable is stored in memory. And we'll do that with 3 variables. Okay. So I'm going to have int, let's call it A, and I'm going to store 22. I'm going to have a car, and I'll call it B, and I'll store it 16. And then I'll have a short, and I'll call it C, and I'll store 20. No, I've already stored 22. Oh, that's okay. I can store 22 again. I'll make it slightly different so that I don't get confused by them. Now, with this, these are going to be declared, and there'll be a space allocated automatically for them in memory. Okay, we don't get to decide where they're going to go. Okay, so for example, let's say A gets put here. Okay, now this is just the data inside A. We're not talking about where the name A gets stored. We don't care about that in this subject. Then B, let's say B gets stored up here. Okay. And then C, let's say C gets stored here. All right. And the values inside them, B has 16, A has 22, and C has 21. Now, obviously, this data would be stored in binary, but we're not going to talk about that yet because that's another system variable, and how it's stored in binary will change depending on the system. We will get to that later in the subject, so I'm just going to show them as integers at the moment. Okay? Oh, short's half of that. Sorry. That was my fault. So short's only 2 bytes. So we'll put that there. Okay, so we've got 21 stored in memory, 22 and 16. These are all suitable values. Remember that our car, if it's assigned, should be able to go up to 128. Int will definitely store 22, and so will a short. Okay. Does that make sense so far? Just say yes or put an emoji in the chat if that makes sense so far. If it doesn't, then say don't know, or you don't understand, or if there's something you want more clarification on. Definitely going to run out of memory. While you do that, I'm just going to add some more blocks of memory. Awesome. So from here, we're now going to be talking about addresses. Now, every single address here, okay, is 4 bytes long. Okay, so if I want to store one of those addresses, I need 4 spots to store it. Okay, and this is something that confuses a lot of students. Okay, just because this one spot has an address that's 4 long, I need 4 spots to store one address. Okay, because I said that my addresses are all 32-bit. So if I want to store one address here, then I'd need 4 spots. If I was using a 64-bit system, then I'd need 8 spots. Okay, this is also one of the reasons, well, it is the reason that you can have more RAM on a 64-bit system, because your addresses are longer. Okay. All right, so let's have a look at that. So let's just move this out of the way. Hopefully it's on this layer. So I'll move that out of the way and we'll make it smaller. Hopefully it's not too small. Yeah, you should still be able to read that. So from here, what we're going to do is I'm going to create a pointer. Now, all a pointer is, as much as it seems very confusing, all it really is a place to store an address, and it tells me the type of the variable in which the address relates to. Okay, so if I have int star pointer 1, okay, this here, and let's do a car star as well, pointer 2, and let's do a short star as well, because we'll need all 3. Okay, so all of these 3 pointers can store memory addresses. Okay, now how do I know they're pointers? Is because of this star here. Okay, so if I add a star after the type when I'm declaring it, then it's a pointer. Okay, so this is the type of PTR1. This is the type of PTR2. This is the type of PTR3. They are not, this is not an int, this is not a car, this is not a short. It is a int star or a pointer to an int. So yeah. All right. So question. What size are each of these? What's the size of the first one? What's the size of the second one? What's the size of the third one in bytes? If you don't know, say don't know. All right. As I've said before, this is an interactive live stream, so please use the chat. Even if you don't know something, mention that you don't know something. So remember that these pointers hold a memory address. Okay. So I'll just wait for a couple more answers or don't knows, and then we'll talk about the answer. Have a go, have a guess. You never know. And as I said, if you don't know, just say don't know. What happens to my chat? Awesome. So we've got a couple of don't knows and we've got a couple of incorrect answers. So the first one is 4 bytes. The second one is 4 bytes. The third one is 4 bytes. Why? Because they all hold an address. They have to hold 4 bytes. As we said, our addresses are 4 bytes. We said that our pointers hold an address. 2 bytes will not hold an address. So it can't be 2. 1 byte cannot hold an address, so it cannot be 1. Okay? So it's always, for this system, going to be 4 bytes. Our pointers in another system might be 8 for a 64-bit system. Okay? And all of the pointers will be the same size. So as soon as you add that star there, it's going to be the size of an address, not the size of the type. Okay? This is one of the most common mistakes when first learning pointers. As soon as you add the star there, you're talking about an address, not a value. Okay? And so as soon as you're talking about an address, you need enough space to store that address. Okay? And on our system, all of our addresses are 4 bytes, so they're all going to be 4 bytes. That is really, really important. Okay? So let's go ahead and draw our variables. So let's say pointer 1 is going to be here. Okay? So in orange is pointer 1. I should have done the background in black. It would have been a lot easier. Let's say pointer 2 is here. And let's say pointer 3 is down here. Okay. So here you can see clearly that all the pointers are the same size, and that is because they have to store an address. Okay. So let's have a look at how we actually store an address. So here, what we're going to do is I'm going to first start by storing the address of the car. So I'm going to go address of, okay? So this ampersand, when used in front of a variable by itself, will act as the address of operator. Okay, address of. And we want the address of B. Okay? So to get the address of B, it's 05. Okay? And that's going to be stored in pointer 2. Okay, so 05. Okay? That whole 32 bits is there to store one address. Okay? Because the addresses are 32 bits. When it comes to storing the int, okay, which is A, we have a couple of addresses. We have OA, OB, OC, OD. The one that the address of grabs is always the first one, okay? So inside of pointer 1, we're going to store, let me do it in another color, OA, okay? Now, how do we know how big the data is? That's where this int comes in, okay? This int says that the address that I'm looking at, okay, contains integer data from here to here because we know that ints are 4 bytes, okay? So for example, if I accidentally put B here and stored 05, then the pointer would think that the int is from 05, 06, 07, and 08. And that is bad, okay? And we'll talk about how to balance your pointers on the left and the right-hand side shortly. Okay, so this is going to be, what do we say, A. And then the short, exactly the same thing. So we got C, and C is at address 1, 2. Okay. Is that making sense so far? What I'll do is I'll just make that smaller. I'll make this small because we don't need this. If that's making sense, just say yes. If there's something you need clarified, say so. And I'll clarify it. Or if you're sort of understanding it and you just want to keep listening, just post an animal emoji. Let's move some of this stuff around. Ugh. Ah, why am I on the wrong layer? No. All right. So I'm going to take a little bit of a diversion from this program right now. And I'm just going to talk about something that we saw a while ago. And this is going to be scanf. Okay. And we've used scanf over and over and over again. And we haven't really had a look at this or understood why we have this here. Okay. So scanf, basically, what does it do? It reads out standard in. Okay. So it reads some information from the keyboard, and then it goes and stores it. Now, what's important here is that, let's say I gave a value. Let's say I gave it the value 8. When I use scanf, it's obviously going to overwrite that value with whatever's read from the keyboard. Now, this is important because scanf doesn't care what's inside A. All it cares about is where is A in memory so I can put the data inside there. Okay? It doesn't want the value 8 because it can't do anything with the value 8. But if you say, put it here, okay, by saying the address of A is some value, it will know to put it in here. Okay? So it's kind of like when you send a letter in the mail, you give the address so you know where to send it. Okay, it wouldn't make sense to bring a letter in the mail to the post office with the house that was going to be sent with it. That just is illogical. Okay, you bring the letter with the address on it and send it. You say where I would like to send this information. This is saying I would like to store this information at this particular location. If I put A here, all this gets evaluated to is 8. And what it's going to try and do is store the memory in address 8 and probably crash your program. All right. So this is why we've been passing the address of operator into scanf. Okay, because I'm saying I want to store it here. Okay, I don't want the value that's in A. That doesn't really help me when I'm trying to store something. Okay, does that make sense? If it makes sense, let me know. If it doesn't, maybe I can explain it in a different way. Or if you just want to keep listening until you understand, you can put an animal in the chat. What's the delay like? What is that delay? What's that stream status? Ugh, not that good. How's the stream? Is it a little bit slow? Just trying to see if I can. It's 7.7 megabytes per second. Cool. Cool. All right, so let's go back to here. All right. Stream's good? Okay, cool. All right, so we've done this. Okay, now if you want to, and really the only time you'll need to do this is when burning pointers or when debugging. Okay, if you want to print out the memory address, you can, and we use a special pointer, a special format specifier for that. So it's going to be %p, okay? And so I could print out pointer 1, for example. Okay? A is 11. What do you mean 11? B is 11. B is 11. 11. I'm a little confused at what you're talking about. A is 10. A is 22 in terms of its value, and it's at address 0A. So A has a value of 22 and an address of 0A. B has a value of 16 and an address of 05. I'm not quite sure what you're asking, so ask again and we can sort it out. So if you want to print out the memory address, you can. So you can use this %p, and that'll allow you to do that. Now, one thing here is try it a bunch of times, compare it with your friends, and you'll notice that the values will change. If you run it sequentially right after each other, you might notice that it doesn't change, and that's just because that space in memory is free constantly, and so it's just reusing it. But if you start making a bigger program where you've got lots of memory, you will notice that it changes. Or if you wait 5 minutes, it will change. Okay, so we don't define where the memory is, but we can have a look at it if we want. But we're not too concerned about that in this part. Now, the other thing that confuses a lot of students, I notice very often, is let's just do one other thing. I'm just going to rewrite this as PTR3 becomes address C. So this is perfectly fine as well. Okay. The star here is talking about the type. Okay. Not the name of the variable. We will see stars before the variable name soon, but it doesn't carry along here. Okay. Does that make sense? Now, what I'm going to teach you now is a trick. And this is a good trick in the exam. And we'll extend this trick as we go along. Okay. So basically with pointers, we don't want any types going into others. So you've seen, for example, we might have a float on the left-hand side and we store an int in it, and that's perfectly fine because obviously a float's larger, and so we're not worried about that most of the time. When we get to pointers, we want to make sure that we've got the exact same types on both sides. Okay. Now, the first rule, to make this easier for you to check when you're doing your program or while you're in an exam and you don't have a compiler, is ampersand or address of adds a star to the type. Okay, and this is a really great way to check if you've done this correct. So here we've got pointer 3 on the left-hand side, and we've got ampersand C. Okay. So pointer 3, oh, why is it not blue? Pointer 3 is of type short star. The C is of type short. And because we've got an ampersand, it adds, or an address of operator, it adds a star to the type. And you can see that their type is equal. Okay. So you want type equality when it comes to pointers, or bad things can happen. As we saw before, if we point to here and it thinks it's an int, it's going to start writing over other bits of memory. Okay. So this is a great way to check when using ampersand if you've done it correctly. Okay. Let's do another example where we check the type equality. So here I'm going to go short star pointer 4 becomes pointer 3. Okay, so here I'm getting that memory address. So I'm already running out of memory. Let me add some more memory. I knew this would happen. I should have done a memory diagram before I started. Maybe if I get a break, I'll do that because it's getting pretty ugly. 28, 29. So here I'm going to create another pointer. This is going to be pointer 4. And all I'm doing is I'm taking the value in pointer 3, which is 1, 2, and I'm storing it into pointer 4. Okay, so this has a 1, 2 as well. All right. So checking the type equivalency here, I've got pointer 4 and pointer 3. Okay. There's no ampersand here, but we can check. Pointer 4 is a short star. Okay, we can see its type over here. And pointer 3 is also a short star. So they're type equivalent, and that's perfectly fine. With pointers, you always want to make sure that the types are the same. Okay? Does that make sense so far? So this is a good little rule that will help you out while doing your programs, while you're testing, and also while you're in an exam. It's a really handy thing to have. So if that made sense, let me know, and then we'll go on to the next part. We do dereferencing or yeah, we'll do dereferencing. That's looking really ugly. We'll start another example soon so we can make this a little bit neater. All right, so basically PTR3, so this is a question in the chat. PTR3 is the variable name, short star is the type. Just like me writing int A, int is the type, A is the variable name, okay? So having a look at both of those, got short star and pointer 3, okay? So this is the type when declaring, this is the name, okay? And here I can write A becomes 4 on the next line, okay? And I can write PTR3 becomes address of C on the next line. I can shorten this and do initialization in one step. So I could write int A becomes 4. Same with this, I could write address of C. Okay. So these pointers still follow the same rules when it comes to declaring. We don't carry the type with it. Okay. It's going to get a little bit more confusing when we get to dereferencing because of the symbols used, but they still follow the same rules with initialization. We can't reinitialize it. So we can't say short star on the next line. We have to say PTR3 becomes address C. Okay, and that just means that I do it on the next line like I would with A as well. Okay, so A becomes 4. Is that what you were asking? Let me know if that made sense. And everyone else, let me know that you're still here and you're still having fun. Why is this so... Awesome. Awesome, awesome, awesome. All right. Now it's going to get confusing. So we've got all these pointers and we're holding memory addresses and it all seems kind of confusing. Now, what you'll notice is, unfortunately, C and a lot of programming languages have overridden operators, meaning that one operator can be used for multiple things. Okay, this AND symbol here, if I put it between two variables, it's a bitwise AND. Okay, but if I put it just before one variable, it's a dress off. Okay, so this makes things difficult, especially when learning, because you can't just remember the operators, because some operators will be different depending on where they're used. And the really, really annoying one is going to be the star. Okay, so the star has multiple uses. The first one is going to be very obvious to you, and that's going to be multiplication. Okay. The second one we've just seen, okay, declaring a pointer. Now, multiplication is expecting some operand, star, some operand. Declaring a pointer is expecting a type, a star, and then a name. Okay. Now we've got two more. Okay. But they are the same thing, but I like to refer them as two. So we've got dereferencing, if I can spell, a pointer, and sorry, I should have done this like this. And it can be used two ways. On the left-hand side or the right-hand side of assignment. Okay. Now, this is where it can get really confusing because a lot of students get confused between declaring a pointer and dereferencing a pointer. And this is why I find it easier to break it into two, depending on which side it is of the assignment, because it can make it a little bit easier to understand. So let's go with the right-hand side first. So I'm going to create another variable, and it's going to be a nice, easy one. It's going to be short. I'm going to call it D. Okay. And I'm going to, I really need a better diagram. As I said, I will clean this up and we'll create a new diagram and I'll make it a proper one. We've got D here, okay? Now what I'm going to do on the right-hand side is I'll do it on the next line. D becomes star PTR3. Okay. Now, when you've got a star before a pointer, okay, star before a pointer, okay, not when you're declaring it, okay. So just a star before the pointer, no type there, okay, no type. Then you are dereferencing. Now, if it's on the right-hand side, you are retrieving, okay, and if it's on the left-hand side, then you are storing, okay. So let's have a look at what happens here. So PTR3 contains 1, 2. Okay, it contains the memory address 1, 2. Now, when we dereference, we're basically saying that we want to retrieve the information at that address. So PTR3 says 12, it goes to 12, and it gets this 21. Now, this is also really important that PTR3 is of type short so that it doesn't grab anything in here, okay? It only grabs those 2 bytes, okay? And then we store it in D, okay? So we store it in D. So we get 21 here. Now, alternatively, let's say I had, let's say pointer 1. And this is on the left-hand side, and I'm dereferencing. And let's say I want to store 48. Okay. So here what I am saying is I want to take 48 and I want to store it in where pointer 1 points. Okay, so I'm dereferencing it. Okay, so pointer 1 is up here and it's got OA. And by having the star there, I'm saying that I want to store the 48 at OA. So I come in here, I overwrite the memory, and now there's 48 in there. Once again, very important that this is an int pointer so that I know exactly how many bytes to write into. Second rule that will really help you out. And this is really confusing, but if you can remember it, it will help. So star or dereferencing removes a star from the type. Okay. And I'll prove that and show how that works. But by using this rule, these two rules, you can check the type equivalency of pretty much any pointer. Okay. And I find these really, really handy. The second one is confusing because adding a star removes a star from the type. But let's have a look at what I mean by that. So I've got D star pointer 3. On the left-hand side, I've got a short. And on the right-hand side, I've got pointer 3, which is a short star. And as I said, adding a star removes the star from the type. They're equivalent. Okay. Same with this one here. I've got pointer 1 star, and I've got the literal 48, which is an int. On this side, I've got an int star, but the star removes a star from the type. Okay, and we've got an int and an int. So these are two general rules that really can help in double checking that you've done the pointers right, because there's not always going to be one star, and we'll talk about that later. There might be 4 or 5 stars before the pointer, and there's lots of levels of indirection, and so it can get fairly confusing. So what I'll do now is just check that everyone understood that as best as they can. I know this is confusing, and this is why I said this is one of the hardest concepts. But what we'll do next is we'll introduce box and pointer diagrams, which is a tool we use to make this a lot simpler. And as long as you understand the basics of this, then you can use this easier tool. So what I'm going to do is I'm just going to have an 8-minute break. Okay. In the chat, just let me know if that made sense or if there's something that needs to be clarified. Anyone that's joining late, skip ahead so that you're at the same pace. As I've said before, I really need you to use the chat as it makes a huge difference. Yes. All right, if you're still here, just mention so in the chat. And then once everyone's back, we'll continue and we'll look at box and pointer diagrams to make a little bit more sense of this and to look at this in a more easier way. Okay, so if you're still here, just put something in the chat. It can be an animal, it can be a smiley face, it can be yes, whatever you like. Let's wait until there's a couple of people and then we'll start back. An evil alien thing. That's cool. What is it? Space Invader. I didn't even know that was there. Awesome. All right. So as you can see right now, this diagram is ugly. This diagram is really ugly, really hard to read, and it has a bunch of problems as well. So the first problem is that our diagram is really hard to read. Relating it to the code is very difficult. The next thing that's bad about it is the fact that these change all the time. So we're just making it up. It doesn't really mean anything. These addresses are arbitrary. So this diagram is really ugly. The other thing that's wrong with it is that I had to keep adding more and more memory as I kept writing my program. And that gets kind of tedious and annoying. So whilst this is good for an introduction, it's a really bad diagram to explain the program. For example, we use flowcharts to describe our repetition and our selection and our sequential code. They do a really good job at being really nice and easily read. And so we want something similar to understand memory. And this is where box and pointer diagrams come in. So let me find some space. Okay. And we'll start having a look at our box and pointer diagrams. Okay. Let me just grab something. See if I can copy some of these across. Open. Okay, don't worry about that. Let's just go back to this. All right, so we're going to use box and pointer diagrams instead. And you will see that these are really nice in explaining what's happening in our code. We're not going to worry about scope yet. Okay, we'll add scope to our box and pointer diagrams in a little bit, but we'll ignore scope for now. Okay. Scope is important, but right now we don't care about it. So I'm going to declare some really basic variables. So I'm going to create int x, and I'll give it the value 5, car y, give it the value 6, and short z, and I'll give it the value 7. Now, how I'm going to draw these instead this time is I'm going to draw a box for each one of these variables. So 1, 2, 3, kind of need to go on this side, 3. Now, this is a dynamic diagram, meaning it changes as the program progresses. Okay, so it's not a static diagram. Okay, so at this point in the program, there'd only be 2 boxes, is what I'm trying to say though. Now, I break those boxes into 3, okay, with a larger spot at the bottom and 2 smaller spots at the top. The top left-hand side basically says what the name of the variable is. So X, Y, Z. The top right-hand side says the type of the variable. So int, char, and short. Now, often what I will do is I will just write I, C, S instead. It's readable and understood quite clearly. So you can do that as well. Okay. Now, in the boxes in the bottom, that's its value. So here we have 5, here we have 6, and here we have 7. Okay. So here, the first thing you notice is that we don't care about the memory address. Second thing we notice is that I didn't have to say that we were using a 32-bit system. Doesn't matter. Okay? It really doesn't matter. Third thing, I can't remember which number I'm up to. Third thing is someone can easily and clearly read this. Okay? Compared to this garbage, this is nice and clean and clear. Okay? I can have a look at this and I know, okay, there's 3 variables. One's an int, one's a char, one's a short. One has the value 5, one has the value 6, one has the value 7. Y, I know the names of them, and so on. Okay? So nice and clear. The next thing I'm going to introduce is a pointer. So I'm going to introduce the pointer int. Actually, I'll just introduce one more variable here, just to show you something else which is important. If I have something uninitialized, we just put a question mark in there because we don't know its value. Okay, it could be any value. All right. So if you don't know its value, you just put a question mark in there. All right, but let's create a pointer. Int star, let's call it P1, is going to take on the address of X. So we draw this in our diagram. Okay, so we've got P1, it's of type int star. And now we're going to store X's memory address. Now, how do we draw this? I could write address of X, but no, there's actually a better way. You'll notice that this is called a box and pointer diagram. And you'll notice that these things are called pointers. And this will really show you why. Because it points to X. Okay? By having its address, it's saying, I'm looking at that X, okay? I'm looking at that one, okay? That's the value that I hold. I hold the address of X. I'm now going to introduce another pointer. I'm going to call it pointer 2, and I'm going to leave it uninitialized. So I've got pointer 2, it's type int star or I star, and it's uninitialized. And then I'm going to go pointer 2 becomes the value that's stored in pointer 1. This is where a lot of students get confused. But remember that the value stored in P1 is this, not this, this, okay? So basically I'm taking that address and I'm storing it here. So P2 now points to X as well. Okay. Very important concept there. What is going on there? All right, so P2 points to X and P1 also points to X. Okay. Once again, we can check that these types are equivalent. On the left-hand side, I have an int star. On the right-hand side, I have an int star. Now we're going to do some dereferencing. So here, what I'm going to do is I'm going to introduce two new variables. Do I need to? Yeah, I will. So I'm going to create int A, and it's going to have a 4. I'm going to make int B, and it's going to have a 2. Okay, so we're going to have A, int B, A, B. And they're just both basic ints, okay, not pointers or anything like that. And this one has 4, and this one has 2. Now what I'm going to do is I'm going to do my dereferencing. So I'm going to do this. I'm going to write, let's say, B as dereference pointer 1 plus dereferenced pointer 2. Okay. So if you go and look at your precedence table, you'll notice that dereferencing is very high up, okay? But if you're not sure, just put the brackets around it and you can force it to be at the start. It does have higher precedence than a plus though. Now, if we dereference P1 and it's on the right-hand side, basically all you do is follow the line and then grab the value. So it's going to be a 5. If we dereference pointer 2, we just follow the line, grab the value. So we've got 5 plus 5, which is 10, and 10 gets stored in B. On this side, we have an int. This side, we have an int. We can double check this in a second. So this becomes 10. Okay, we can check that our values are type equivalent. On the left-hand side, we have an int. On the right-hand side, we have dereference P1. So P1 is int star, and as I said, when you add a star in front of it, you remove a star from the type. Same thing here, and an int plus an int gives an int. So they're type equivalent on both sides. Next, what we can do is we could basically dereference to change the value. So I'm going to put the star on the left-hand side now, and I'm going to say P2 becomes, let's say, A plus B. So here we have to evaluate the right-hand side first. So we're going to have A, which is 4, B, which is 10, and we get 14. Okay, all as an integer. And we're going to store it at P2 dereferenced. So we go to P2, follow the line, and that's wherever it points is where we're going to store the result. So we store 14 in here. Now, what you can see that's kind of powerful is right here, we just changed the value in X without talking about X. Okay, and that's quite powerful. The fact that you can see quite clearly no X, but the value is changed in X. Okay, so this just shows that we are actually changing the value, and you can print out the value if you like, just using a printf to double check that I'm being honest, but I can guarantee you that it is correct. All right. Does that make sense so far? And can you see the power of the box and pointer diagrams? So if that makes sense, just say so. If it doesn't make sense, let me know what doesn't make sense. There might be a little bit of a delay. I don't know what the delay is. Check. Oh, a bit right went way up. Awesome. Awesome. So let me get rid of some of this stuff, and then we'll talk about double pointers. So if you're not understanding, tell me what doesn't make sense, and then we can go through it. Right, so I'm going to get rid of this, and I'm going to get rid of P2. So I'm just going to bring my program back to here, and then we'll talk about double pointers. That was 5. So I'm going to fix that up. So just clean all this up. Okay, so we're back at the start again. Now, I'm going to go back over to our horrible diagram, because we kind of need it for a little bit longer. The question is, what's the size of pointer 2's address? Or pointer 1's address? Or pointer 3's address? What you'll notice in memory is that all of these pointers also have an address. Okay? So all of our pointers also have an address. And they are also going to be 4 bytes long. Okay? So if I wanted to store the address of pointer 4, I need 4 bytes to store it. But what's the type? Well, the type is going to be the pointer that points to it. So remember, if I want to store the address of A, because A is an int, I need an int star to store that. If I want to store the address of B, because it's a car, I need a car star to store that. If I want to store address of C, because C is a short, I need a short star for that. So if I want to store the address of pointer 2, which is a car star, then I'll need a pointer which points to a car star, okay, to store its memory address. So let's go back to our program and do it using the box and pointer diagrams, because it's a little bit easier. So I want to point to P1. Okay. I'm going to write int here just so that we can have a look at our third little thing that's going to help us out. So I'm going to add int star, and I'll call this PP1. Okay, and here I'm going to store the address of P1. So I create my pointer, and this is going to be PP1, and it's int star star. And it has the address of P1. Now, let's have a look at this. We changed the value to 10. We stored the result in B, I'm pretty sure, but you're a bit behind. All right. So from here, we can see that we've got a pointer to another pointer. Now we're going to do a type check to make sure that both the left and the right-hand side are equivalent. So on the left-hand side, we have int star star. On the right-hand side, we have P1, which is an int star. And we said that our rule, our little shortcut and check, is that ampersand adds a star to the type. So we've got an ampersand there, so we add a star to the type, and we can see that they're equivalent. Okay, so we can see that these are equivalent. Okay, so this is perfectly legal and safe. Okay. Now from here, we can do a couple of things. So, for example, what should I do? Maybe I'll create no. So I'll do an easy example first. So I'm going to create another variable. I'm going to call this W. Okay. And what I'm going to do is I'm going to say W becomes dereferenced PP1. Now, it's on the right-hand side, so we're retrieving information, okay? Remember, everything goes back pretty much to storage and retrieval. And I think if you understand storage and retrieval, you understand most computing aspects. So we've got 2 stars this time. So we follow it once, we follow it again, and we get the 5. And we store that in W. Okay, so we'll create another variable called W, which is an int. Okay, and we're storing 5 in there. Okay, originally it was 8, but we grabbed the value 5. Okay, so the number of stars tells us how many arrows to follow. Okay. We could also do this. So I could go star star PP1 stores the value 865. So what we're going to do here is we've got 865, and we're going to store this at PP1 dereference twice. So 1, 2, and we store 865 there. Now, let's do a quick check to check our sanity. So on the left-hand side, we have an int. On the right-hand side, we have an int star star. And as I said before, a star removes a star from the type. So we've got an int on the left-hand side, int on the right-hand side. We've got an int on the right-hand side this time, and we've got an int star star on this side, but the 2 stars remove each star, and we've got an int and an int. Ugh. Okay, so we've done our check and that works. All right, so let's take another step back. So I'll get rid of all this. I'm going to keep PP1 again, and then we'll talk about another check, which is very, very handy in the exam because you'll need to do this in the exam. So if you're in the exam and you're drawing your box and pointer diagrams and you want to double check that they are correct, okay? Pointer should only point at something with one less star than it has. Okay, and you can see this. We've got 2 stars pointing to something with 1 star, which points to something with 0 stars. Okay, so this is sure. So this is another trick you can do. All right, so it doesn't really matter the value. So I had that doesn't actually matter. I don't need the int. So we had dereference, pp1 becomes some value, let's say 48. We have a literal 48, and it's going to be stored somewhere. The left-hand side is always storage or an L value. And basically, we are dereferencing, which we talked about before. Okay, the left-hand side is storing. So basically, the stars, we just follow them twice, and then we store in that location. So 1 star, 2 stars, and we store the 48 here. Okay. We can do a check to make sure this is balanced. Okay, so we have 48, which is an int. We have int star star. We remember our rule that I said before. A star removes a star from the type. And so we have an int on the left-hand side and an int on the right-hand side, and so it's valid. If you had something like that wasn't valid, so if you had something like this, okay, this is really dangerous. Okay, so here we have an int on the right-hand side, and here we have an int star star. Get rid of 1 star on the left-hand side. What this will do is it will store 48 into P1. Okay, if we store 48 into P1, it's going to be pointing at some random memory address. And when it does that, if we dereference it, we could crash our program. Okay, we never want to dereference something we don't know exists. Okay, because it most likely will either crash our program or cause undefined behavior. So return that. Does that make sense? Yes. PP1 is int star star. Now, we won't see the power of double pointers that much until we get to some more advanced things. You can also do triple, quadruple, as many levels of indirection as you like. But for most problems, it's going to be 1 star or 2 stars. 3 stars are not as common unless you're doing something quite complex. 4 stars, you don't see very often at all. And 5 stars, same thing. And you can keep going, but unless you're doing file systems or some very complex maths, optimization, you're probably not going to see it. All right, next one I'm going to do is I'm going to introduce another int. So I'm going to do int w is, I don't know, 8. And this example is really good because it will help understand this indirection. So what I'm going to do here is I'm going to dereference pp1, and I'm going to give the address of w. Okay, so now we're getting a little bit more complex because now we have ampersand on one side, a dereference on the other side, we have a double pointer, and we have a normal int. So this is getting a little bit more confusing. So on the right-hand side, we're returning the address of w. Or not, we're giving the address of w. So we know that we give a pointer back to the left-hand side, which is going to store it. Where are we going to store this? We've got pp1, and we follow the arrow once. So we override this here, and now p1, doesn't need to be so ugly, is pointing at w. Okay, so it's pointing at w now. Okay, let's do a check and make sure that this is all safe. So on the right-hand side, we have w, which is an int. We go back to our rules that I said before, and ampersand adds a star to the type. So we've got an int star. pp1 is int star star, and we remember our rules, which said star removes the star from the type. So we go over here and we remove a star from the type, and we get int star becomes int star, so it's perfectly balanced and valid. The other thing we can do is we can do our third check. Okay, we've got a star star pointing to a star pointing to an int, so that's perfectly valid as well. And these are the kind of checks that you should do, especially when you're in the exam and you can't check this. The other thing is that we're reaching the stage where the compiler may not tell us when we've done this wrong. Okay? Is that making sense so far? This is getting a little bit more complex, but in terms of double pointers and stuff like that, this is as complex as we need to go right now. I might do one more. Well, yeah, I might do one more complex example, but I think you'll get it. I'm going to change this to int. Star 2. So I'm just adding another pointer here called p2, and it's going to point to x now. Okay, pointed at x, and it's a type int star. Okay, and then what I'm going to do is I'm going to go star p2 becomes star p2 plus star star pp1. Can anyone tell me what is stored in P2? In X, sorry. So after that, what is stored in X? And I'm just going to have, all right, so have a try at that, okay? And I'm just going to be back in 3 minutes. All right. If you're still watching, make sure that you're up to where we are. If there's any questions, let me know. And I just want to check. Still we go. All right, so I'll be back in 3 minutes. I just need to answer an SMS. But while I'm there, try that question. If you don't know, say don't know. All right. Maybe 13, maybe double pointer a bit tough. Cool. All right. So let's have a look at this. The great thing is that, yes, the double pointer would be tough, but our box and pointer diagrams actually makes it a lot easier than you might think it is. All right. So let's have a look at dereference P2 first. So we go to P2. We're on the right-hand side, so we're grabbing values. Okay, whenever you're on the right-hand side, with dereferencing, you're grabbing a value. So we dereference once. So however many stars is however many lines you follow. We've only got one star, so we follow the line, and we grab that 5. Plus, here we've got 2 stars, so we just follow the line twice. 1, 2, and we get our 8. Okay. We then add these together, so we get 13. Then, because of the left-hand side, what happened there? The left-hand side happens last, and so we're going to store wherever this points. Okay, so we just follow this however many times, and there's only 1, so we follow this once, and we store it in X. Okay, so 13 gets stored in X. Okay, so by looking at this code by itself, yeah, it can get really confusing. Really confusing about where everything's going to be stored. But if you're able to draw a box and pointer diagram, it's literally just following the lines, however many stars you see. So it makes it a lot easier. And it's a good diagram because it's not this horrible mess. Okay? It's a nice diagram because it should make your lives a lot easier in solving some complex problems. So get used to drawing these diagrams. We're going to make you draw some in the next lab. And you will have to draw these in the exam. Yeah. All right. Is that making sense so far? Now, some people said that they wanted to talk about functions. What in particular about functions? Because I've got two options. We can talk about functions, or what I'd much prefer to talk about is functions and pointers together. Okay. I'd much prefer to talk about that because we can probably sort out some things at the same time. But if there's something particular about functions that you want to talk about, then I'd much prefer to go to one so we can focus in on that. But I don't know what it is that's confusing you with functions. So if you can tell me, we can do functions. Otherwise, we can do functions and pointers. Yes, you have to use box and pointer diagrams in the exam. You'll have to draw a bunch of diagrams in the exam. Or we can go talk about the exam. So this is just the order of information. So what do you want to talk about next? I still want to talk about functions and pointers, but all right, so I'll just give you a second to answer that question. I do want to cover two, but I'm happy to go talk about the exam, or if there's something in particular about functions. The exam would be a nice break, actually. Oh, I had a nice diagram there. Exam, cool. All right, so let's grab the exam. We're gonna go 3 then 2. I think that's easier. It's easier for me too, because the exam's easier to talk about. It makes it a little bit lighter. All right, so you'll notice that I've unlocked a tab on LMS, which has two practice exams. Okay. And they're very, very similar. And we'll talk about why they're similar and about your exam in 2019. So basically, the exam is very similar between the first years and the masters. The only difference is that the masters will have one extra question. Okay, so the practice exams is designed for everyone. Okay, so it doesn't have the extra question. Okay, but the first part for the masters or the whole exam for the undergrads will be exactly the same. Okay, so the first question, it might not be in this order, but the first question will be multiple choice. It's not worth very much. This year, I think it's, I'm trying to remember, it's very similar in terms of marks. It's basically a mark per minute. Okay. So there should be about 10 to 15 questions here, giving you a mark per minute. Now, these questions are more theory than practical applications. There might be a couple of practical application questions, but most of them are theory. So example, what's the storage size of a car in bytes? What's legal, what's not legal? What function do we use? So more theory-based stuff from the lectures, okay? So the first question will be multiple choice, not worth that much, but about 15 minutes of your exam. Okay, so about an eighth of the exam for the undergrads and about a tenth of the exam for the master's students. The second question will be tracing questions. So this means that you can follow a program Excellent question. We'll come back to it. But all right. Sorry. One of the students is asking really good questions, but not at the right time. All right. So basically tracing questions, you can use your box and pointer diagrams or just a simplified tracing diagram to work these out. Basically, what you want to do is trace what's happening in your program and then print out the results. Using a diagram will help dramatically, okay? It will make sure that your answer is correct and that you can show you're working. You don't have to show you're working, but it would help, and there might be some consequential marks possibly. Okay. So that will keep going. You'll notice that a lot of these are recycled quiz questions or modified quiz questions. So practicing the quiz will help. I've released the quiz for weeks 2 to 6 on the exam tab as well, so you can practice that as much as you like. You've probably all seen this example recently. So there's a bunch of those kind of questions, and they're worth about 25% in this practice exam. I can't remember how much they're worth in this exam, but it's about a quarter of the exam, okay? Approximately a quarter of the exam, right? So it's quite a significant part of the exam. So basically they'll all have printfs, and you just print what is printed. Then you will have your box and pointer diagram questions. So you can see here that we've got pointers, we've got addresses, we've got quite a few pointers, we've got pointers in functions, we've got some dereferencing that we've been talking about just today, and you will need to show the box and pointer diagram at particular points. So for example, at line 12, what's the state in memory? Using a box and pointer diagram. Now this one also introduces scope. Your questions will be slightly better than this. I don't actually like this question, but we'll get to that. So for example, what's the state of memory? It's step 21, etc. There's a, I'll show you later. And just keeps going, keeps going, keeps going, keeps going. So you have to draw quite a few box and pointer diagrams. And that should be about, so 21%, about a fifth of the exam. Maybe a little more this year, I think. I don't think this is question 4 in the exam this year, but somewhere in there, there'll be a small question that will ask some hard questions. So it'll ask some questions about errors and stuff like that, and it'll be worth very little. Okay, this is more to challenge the students that are right at the top, that want to get 99 or 100 for the exam. It's very few marks for the time limit. Okay, so my recommendation is if you do see these questions, have a look how many marks there are, and if you're not strong enough to do these, skip over it, because you shouldn't waste time on these questions. These questions are designed to compare those students that are right at the top. So if you spend more than 6 minutes on this question, just skip it and go ahead. We'll talk more about that later, but there will be some harder questions based around error messages and stuff like that. There'll be a flow diagram question or multiple flow diagram questions, which is worth another quarter of the exam. Okay. Basically here, you'll have to draw a flow diagram for a problem or a set of problems. Okay. So you get a description. Okay. And then you draw the flow diagram. So I recommend you use your labs as references for practice for this. Use your labs and start drawing some of those flow diagrams so you can see what's happening. The last question for the first years and the second last question for the master's students will be a full program. And it will follow this same format. It will have a couple of functions and it will give you the function prototypes. We always give you the function prototypes just so you can't change them or anything like that. You will need to always create main, okay? And then it will tell you what the functions and what main needs to do in the program. It will always involve dynamic memory, okay? So we'll always have some kind of dynamic memory in it. We haven't got to dynamic memory yet. I just, before we started the stream, or actually while we were starting the stream, just released the first video on that. And I've got another video which I'll upload just after this. And so this question will use dynamically allocated memory, okay? Because that is a huge part in the subject, okay? And so it'll ask you to do something and then you'll have about a page to write it on. It's not very long code, but it is fairly difficult because of the dynamic part. And this allows us to test your syntax knowledge and your ability to write code or write basic code in an exam setting to show that you understand what's happening. From there, there'll be 1 or 2 extra questions for the master's students, and they could be anything. It could be theory, it could be writing another program, it could be filling in parts of a program, etc. Okay? Does that answer those questions? Now, the other thing is that on the exam tab, you'll see a file called Lab 12. Now, in previous years, so not last year, but the year before, this subject was only for first years and an elective for master's students. And because of that, the subject was a lot more difficult. It's a bit easier now, but it also meant that there was no second lab 0. We started lab 1 in lab week 2. Okay, and because of that, we actually had a lab 12 that basically was exam practice, and you can use this as exam practice as well. And there's a bunch of questions there that you can use and go through and have a look at. There's a box and pointer diagram question there, which is really, really good. It's better than the practice exam one. And it goes through every single step of the program. It doesn't just choose a couple of points, it chooses every single step in this program. So you can go to LMS, and what you'll find is the box and pointer answers. Okay. There's one which is just a photo of the whiteboard when we did it in the lab as a group. And the other one is basically every single step. You can see here that we've got scope. Okay, so we've got those outer boxes, but this goes through every single step of the diagram. So this question is really, really handy, and we'll refer to this later because when we did have this lab, it was really, really handy for the students to go through every single step of a more complex problem with box and pointer diagrams and seeing it at every single stage as well. Okay, so that is there for you for practice. There's a couple of old lecture slides as well that you might find useful. There's the types of questions. These are all old. The past exams are pointless. I'll talk about why later. These are more important. Okay, 2017 and 2018 practice exams, because they have the same format as this year's exam. Okay. And that's about it. I'll release some other stuff as we go, but that's the exam. Sound good? Is that the information that you wanted? In terms of dates, you'll have to check that when they're released. I'm not sure when the dates are yet. But yeah, not too hard of an exam, and we will prepare you. Okay. It's quite a few diagrams, a bit of multi-choice, a couple of tracing questions. It's not too difficult of an exam. Okay, all that information is there. Right, you should be able to get a good mark easily in the exam, as long as you, if you've been following all the videos, all the lectures, anyone. So we did some stats. Those students that showed up to 90% of the live streams all got above 80s in the subject last year. Last year we didn't have the lab videos, but I imagine the same would be with the lab videos. With the lectures, anyone that showed up regularly got a very high mark as well. So the engagement really does change your mark in this subject, and you can get a really good mark quite easily just by engaging quite often. All right, I'm going to have an 8 or 9 minute break just to fill up my drink, and I've been talking for 2 hours, so I need to take breaks. So just give me, I don't know, let's say 9, let's say, what's the time? Let's say a 10-minute break. Okay. Go grab a drink or something, and then we'll talk about functions and pointers. All right, if you are still here, let me know. There's a couple of people. What's the question? Star P2. Just wait till everyone's here. And then we'll answer this question that was asked by one of the students before the break. Beautiful. So one of the students asked before the break, what if I did star P2? So let's do an example of that. So if I went int h becomes star P2. What happens here is that we dereference once, and then we can't dereference again, and our program will probably crash. Okay, so there's only one level of indirection that P2 can support because it points at an int. It can't go further than that. And we can validate that by having a look at making sure it's safe by following the rules that we talked about earlier. Okay. So on the left-hand side, we have an int. On the right-hand side, we have an int star. One star will remove one star. The other star will make this invalid. Okay, and our program will probably crash. Okay, or cause undefined behavior, but most likely in this case, it will crash. Okay. So here, this is not valid. Okay. And we need to make sure that we do a check, okay, using the rules that I said earlier, to make sure that it's valid, or else, yeah, you will have bad things happen. Okay, does that answer the question? So that's bad. Okay, so we can never see a double dereference of a single pointer, okay, because it's only got one star to work with. We can see two dereferences on a star, or one, depending on the situation. But a single pointer can't support two stars. All right, let's move to functions and pointers. Hopefully I've got enough room. I've got plenty of room. Let's go up a little bit. Where's this top of the page? There it is. All right, so basically what we're going to have a look at here is we're going to have a look at pointers, scope, returning more than one thing from a function, which is very, very handy because obviously we're quite restricted in only being able to have one thing returned from our function. Oh, shit. All right. So I'm going to create main to start with. Okay. And let's just make it this big. I'm probably going to run out of room, but that's okay. What I might do is I might write this and then make it smaller. So what I might do, because my handwriting isn't that small, but I can make the text smaller. So I'll make that return 0. And we'll include standard IO H, and we'll also add a function prototype. So I'm going to call this Matt's pointers. And I'm going to pass in an int called, let's say, x, a int star called y, and then an int star called z. Okay, not very good names, but good names for an example. Okay. So I'm just going to make this a little smaller so we can fit a little bit more on the page. Hopefully this doesn't stuff me up. Okay, because I need to do the pointers example as well. All right, so I'm not going to worry about main. I'm going to jump straight to my function. I'm going to write that. So I'm going to write void Matt's pointers. I'm going to call this x again, int star y, and int star z. Now, some of you might be asking, no, you don't need to include these in the function prototype, but you can if you want. It doesn't make a difference. So inside of there, I'm going to make x become dereferenced y. I'm going to make dereference y become dereference z. And I'm going to make dereference z become x. Okay, and these are all valid. Okay, because if you have a look, we've got an int on the left-hand side. On the right-hand side, we have an int star. A star removes the star, so we have an int becomes an int. We've got y, which is an int star. By adding the star, we remove a star, we get an int. We've got z, which is an int star. By adding the star, we remove a star from the type, so we've got an int. So we've got an int becomes an int. And then the last one, we've got int star becomes int. But we've got this star which removes the star from the type. And so we've got an int becomes an int. So all of these are valid. All right. Up in main, I'm going to create 3 variables. And I'm going to purposely call one of them x, just to reinforce a point about functions that we talked about last week. So I'm going to set that to 4. Maybe I should do something a little bit more interesting. Let's go. That. Just to make it a little bit more interesting. Now that's a multiplication there. Okay, it's not a pointer because it's between 2 operands. This one's in front of something, and so it's a dereference. I'm going to create another variable called, let's call this one b. Set it to 2, and then I've got c, which is 3. Okay, nice easy values. I'm going to create a pointer in here. So int star ptr, and that's going to take the address of, let's say, c. Then I'm going to do my Matt's pointers. And I'm going to pass to this x, the address of b, and ptr. Then I might print out the values. So printf, what do I want to print? I want to print x, b, and c. So they're all ints. So x, b, c. So I've got x, b, and c. All right. So I'm going to make some of this a bit smaller so we can draw the box and pointer diagrams, which is going to be really important for this question. All right, so smaller. We move that up a little bit. Hopefully you can still read this. It's not too small, but I just want a bit more room. This is the problem with coding on a what are you going on about? Beautiful. Right, stop. All right. So we've got an example here, and what I want to do is I want to work out what's happening. Now, before I start, I just want to draw your attention to the function. We can also test that we are passing the right thing to our functions using the same logic. So x here is an int. X is an int. The address of B is an int star. Remember that when we have the address, we add a star to the type, int star. So it's perfectly fine. PTR is of type int star. We have an int star. So it's perfectly fine. So you can follow the same rules of dereferencing and adding the address of operator to check the validity of what you're passing to your function as well. Okay, and this is really, really handy, and it means that you won't make mistakes in the exam or in your program and have unsafe code. So always I recommend to make these checks when you're calling a function or you're assigning something or dereferencing something. All right. Now, with our box and pointer diagrams before, we didn't worry about scope. This time, we are going to worry about scope. Okay. So we need to draw the scope. Now, we know where our program starts. It always starts in main. Okay. So we're going to start in main. Okay, and we're going to draw the scope of main. And we're probably going to run out of room, but we'll see how we go. Probably could have done that even bigger. I might do it a little bit bigger so we've got a bit more room. How many variables? I only need 4. Okay, maybe I won't run out of room. We'll see. So I'm going to draw a box, okay? And this represents the scope of main, okay? We start our program and we create X, okay? Following the rules that we talked about before, I've got X, it's an int, and it has the value 4. We've got B, which is an int, and it has the value 2. We have C, which is an int, and it has the value 3. We then create this pointer, okay? Nothing too surprising yet. And then we'll talk about this function, and this is where it gets interesting. So that's PTR, and it's an int star, and it points at C. Okay. Now, what we're going to do is we're going to call this function. Now, what I'm going to do first is I'm going to draw the function. And this is Matt's pointers. Okay, I'm going to draw in all of my parameters, okay, because something needs to be passed into them. Okay, and our parameters are declared as the function is called. Okay, so we'll draw all those, and we've got an X, which is an int, we've got Y, which is an int star, we've got Z, which is an int star. Now, important, extremely important thing. This x and this x are not the same variable. All right. So that is something that a lot of students stuff up and make mistakes. My advice is try and give everything a unique name where possible, so you don't have that problem, especially while learning. But be very careful not to fall into that trap. All right. So whatever's here inside of the brackets, so we've got x, we've got the address of b, and we've got PTR, needs to be evaluated before it's sent into the function. Okay, this just follows the normal rules of functions, which we did last week. Okay, so x evaluated is 4. The address of b is just going to be some pointer to here. Okay, and PTR is going to be this pointer here. Okay, so it's this red pointer here. Okay, so we pass these into the function. So the first value that gets passed in is the 4. The second one is this pointer, and that gets passed into y. And the third one is this red pointer, which is z. Now, this is really, really powerful. Okay, this is where we can actually get out of scope and access stuff from outside of our own scope. Okay, so we couldn't do this before, but now we can. So we can see here that we've got this link between the two functions. So this is really, really powerful, okay? Because obviously when I'm inside of Matt's pointers and I try and use B, I'm in this scope. I can't access B. It's just going to say variable undeclared, okay? There is no B inside of these two braces. Okay? But I have the address of B. So like scanf, I can say, I would like some stuff stored in that location, okay? Just like scanf, okay? Remember scanf, we pass the address of our variable. We're doing the exact same thing here. We're passing the address of B, and we're also passing the address of C, meaning I can go and store something in that location. I can also retrieve, which you'll see shortly as well, okay? So let's have a look at this line here. So we've got x becomes dereferenced y. Dereference y, remember that we are on the right-hand side of the assignment, meaning we are doing retrieval. So if we're going to do retrieval, then we follow the line and we get this 2. And 2 gets stored in x. Now, big thing, big common mistake on exams, it doesn't change this x. It changes this x because we're inside of this function. Now, you'll notice also that we couldn't write x becomes b in here because b doesn't exist. But we're able to change something in main. No, we weren't able to change something in main. We're not up to that stage yet. You were able to access something from main even though it's not in scope. All right. Now we get to the next part. So we've got star y becomes star z times 2. So now, dereference z, it's on the right-hand side, so we're retrieving. So we go up, retrieve our 3. We multiply it by 2, giving us 6. Where are we going to store that 6? Give me a sec. Oh, okay, I'll fix it. We have 6 here. All right. And we're going to store that at where y points. Okay, so we're dereferencing y, and y is on the left-hand side of the assignment. So that means we're doing storage. So we're going to take that 6 and we're going to store it in B. Okay, so you can kind of see how scanf works now. Okay, so from inside of scanf, we're able to change the value that's in main. Okay, and here we're able to do the same thing. So we're able to set B to 6. And then what I'm going to do for this last part is I'm going to take my x, which is 2, and I'm going to set it to where z points. So I'm going to take that 2 and go all the way up here and make that a 2. Then we leave the function, meaning that basically when we leave a function, we lose all reference to it. Okay? And when we lose all reference to it, it's as good as gone. All right? So that's gone. All right? And we're back in main. And you can see why is my eraser so tiny? What happened? That's not my eraser. Oh, because I'm doing black. Okay, sorry. I thought I was using the eraser. What is going on? Where is the eraser? Wrong layer. So you can see that we changed the values in main whilst we weren't in main. And this allows us to return more than one thing from a function. All right. Does that make sense? What are we doing? 6. If that makes sense, let me know. If there's something unclear, let me know. I'm just about to submit this. If anyone wants to add anything. Oh, whoops. All right, is there any questions? So also, if you want to leave any feedback for last week, I forgot to submit it, so you can do it now. Now, the other thing, 5. Oops, sorry. All right, is there any more questions? Has anyone got any questions? I think we've covered everything that you need to know for this week. I'm going to go over this stuff again in the lab when we do the tutorial lab. Basically, it's going to be this again, but I'll cover a couple of other things. Actually, I think that's basically it. Let me double check. Yeah, so you should be able to get through it fairly quickly if you understood this well. There's more videos on the YouTube if you want to Continue. I haven't put these on LMS yet, but they are there. There is a playlist if you want the whole playlist. You can find that as well. Is there any questions? Anything else? Any other problems? Anything like that that you want to raise? Or are we all good? What was I looking for? Oh, I was looking for PES. So, for those that have been here for the last, I don't know, 3 hours or something, that shows excellent commitment to your studying and education, and you should do really well in this subject. So thank you for coming. I think this is a good little service, and as I said, I'm happy to support you guys. And this time the chat's been really good, so thank you for coming. Hopefully that's helpful. There's some feedback there which I need to submit tonight. If you want to fill it in or not, it's up to you. There's some other feedback that's coming up soon, which I'll let you know, which is probably a bit more important. But other than that, have an awesome night, and thank you. I'll stay on for another minute or two just to see if anyone has any last-minute questions. Other than that, I'm just going to try and get something. Yeah, so there's one task that you need to do. The other task is the tutorial. So at the front of the page, and I've actually got it up right now because I need it for Bendigo. So task 1 is run by the demonstrators or myself for most of you, and then the second task is submitted as normal. The second task is the complex numbers one. Make sure you get it checked off because you'll need it for the assignment. Okay, so make sure someone has a look at it before you submit it. I've also given a video explaining how to do it. Triple, double, quadruple check it. Don't just use the examples here. Run a bunch of examples on it, because if it doesn't work, then your assignment's not going to work. Okay, so it's really, really important that you get this working. Okay, so the big ones are going to be the multiplication and the division. Go get a complex number calculator online and try and find a couple more examples and just test it, I don't know, 10 or so more times with a couple more examples is my advice with that. I just explained that. Kill. Just updating the document now. Indigo notice something. What? All right. Thank you very much. We'll go.